All right, ladies and gentlemen, today we're going to work on Wednesday's math lesson. Okay, I'm going to go ahead and share my screen, which I am. All right, so today we're going to look at being able to graph the points in the first quadrant of a coordinate plane in order to identify and interpret the points to solve problems. We're also going to do what we have been doing all week, which is using two given rules in order to create two number patterns. So now we're going to put together what we have learned in the past along with what we have been doing this week. Okay. And again, of course, I have the same two pictures on the bottom, which are function tables. Function tables, of course, are involving rules, and there's typically an input and an output. And if you watch the previous videos, you would know what I am talking about. Anytime there is an input, there is going to be a result. That would be the output of it. And usually it is marked with an X and a Y. So we're going to create the table, use the rules, and now be able to even graph the particular points. So let's get started. I'm going to go ahead and read this problem to you. You can read it along and just watch, of course, how Mr. Oneal's thought process, and make sure you're listening, how Mr. Oneal's thought process would be to solve this kind of problem. Okay, so first we have, in math class, Fernando learns that the rule add 1 to the side length of a triangle with equal side lengths results in the rule add 3 to the perimeter. Write the values generated by these rules in the table. Okay, so here we see the table. We see it is labeled side lengths in inches as well as perimeter. So now let's go back to the top and break down what they're telling us, okay? Fernando learns that the rule add 1 to the side lengths of a triangle with equal side lengths results in the rule add 3 to the perimeter. Now, some key terms that you may know or be familiar with, especially perimeter. Perimeter is basically counting around the entire thing, right? The perimeter of it. And then the fact that they're talking about a triangle has 3 sides. And with it being said, with equal side lengths, we then know if we add 1, if we were to go around the triangle, we could then realize that add 3 would make sense if we are going around the triangle to get the perimeter. So looking at this chart now, all right, again, let me just highlight some of what was being said. So add 1 side lengths of a triangle with equal side lengths, and then add 3 to the perimeter. So here we see the side lengths in inches. We have 0. Perimeter, therefore, would be 0. That makes sense. If you're not traveling anywhere, if there are 0 side lengths, there's nothing to go around. But if we have 1 side length, then the rule add 1 could then go here, which would be 2, because 1 plus 1 is 2. Add 1 to that, we would get 3. Add 1 to that, we would get 4. Okay. So now we figured out the different amount of side lengths, and we could, of course, keep going. But now let's work with the next rule that they have. If we're adding 1 and we want to find the perimeter of a triangle with equal sides, then the rule add 3 would also make sense. So if we had 0 and we added 3, we would get 3. And that's what you see there, right here. Well, if we add 3 to that, we're going to end up getting 6. If we add 3 to that, we're going to get 9. And if we add 3 to the 9, we get 12. So here we basically have completed our chart with the side lengths of a triangle, as well as looking at the corresponding perimeter. So now let's use the same chart, and I've had it filled out here. So let's use this chart now and go ahead and answer these questions. First one says, use the values in the table to write the ordered pairs that relate the side length to the corresponding perimeter. Okay, what does that mean? Well, that basically means let's take the side lengths in inches as well as the perimeter and then create ordered pair. Now, if you remember and go back to the vocabulary for what Mr. Neal gave you, ordered pair means 2 numbers. I have 2 numbers that are being formed, they're being ordered, that I can then use to eventually graph. So I need 2 numbers. What are those numbers going to be? Well, I need an X coordinate and I need a Y coordinate. Okay. So one way of trying to figure out, well, what is X, what is Y, is by looking here at this graph. Okay, let me kind of circle this for you. Looking at this graph here, right? If I look at this graph, I see my x-axis right here, and what is below it is label the side lengths, right? So that means that I could go ahead and label this x, and then I notice that the perimeter is along the y-axis, right? Up and down. So I'm going to label perimeter in the chart y. So now I can easily come up with the numbers to create an ordered pair. Remember, an ordered pair needs to look like this. X, comma, y. All right. So how then would that be so? Well, let's go ahead and fill this out. I'm just going to erase this yellow line here. So that way we don't get mixed up at all, right? Okay. Okay. All right, here we go. Ordered pair time. So remember, ordered pair should have parentheses. So our first ordered pair for x and y we have is 0, 0. So I'm going to write 0, comma 0. Next, we have 1 for x, 3 for y. Then we have 2 for x, 6 for y. Then we have 3 for x, 9 for y. And finally, we have 4 for x, 12 for y. Now, I know for a fact that my answers are correct. Why? Because I created an ordered pair of what it should look like here. And then I'm able to form and take these numbers from the chart up here and be able to put them here. Okay? All right, cool. So now we have ordered pair. So we have done B. We're good to go. C says graph the ordered pair on the coordinate grid. So now we need to graph it. Now, let me just erase this line here. We should have an idea. Up and down is Y, and horizontally is X. So I'm going to go ahead and I'm going to use blue to put the dots, and then I'm going to connect the dots, okay? So let's start with our first ordered pair, 0, 0. Another name for that is the origin, 0, 0. That means I did not move to the right on the x-axis at all. I did not move up on the y-axis at all. So which means that point is right here. Right, it's 0, 0. Okay, cool. Next is 1, 3. I'm going to move to the right 1 time and up 3. And you might be saying, Mr. Now, how do you know that you're putting the points in the correct area? Well, if you look at the x-axis as well as the y-axis, they're going in intervals of 2. They're skip counting 2, 4, 6, 8, 10, 12, etc. Right? So if I have a line in between, that means that it would be a 1. In between the 2 and the 4 would be 3. In between 4 and 6 would be 5, etc. Okay, so that's how I know I'm plotting it in the correct area. Next ordered pair is 2, 6. So I'm going to move to the right on the x-axis over to 2 and up 6. It's going to put me right there. Next, I have 3, 9. So I'm going to start at 0, go over to the right on the x-axis to 3, and go up to 9. And that's going to put me right here at the intersection, right? Remember, it's where x and y meet. And finally, we have 4, 12. So I'm going to go to the 4 on the x-axis and up to 12. That's going to give me a point right here. So now I'm just going to simply connect these as best as I can. Okay. And that right there is our answer for C. So let me just draw an arrow. Oh, not that. Oh, man. Sorry about that. Okay. Now, there's my answer for C. D, how does the perimeter relate to the side lengths? So that kind of means that you can look at the graph. I think what would be helpful, ladies and gentlemen, is looking at the chart. So how can, or how does the perimeter relate to the side lengths of what they're asking, what they're talking about? Well, I can say the way the perimeter man, this board is silly. The perimeter relates to the side length. Again, I like complete sentences. Side length is that. Now, before I finish and answer it, let's think about it. How does the perimeter is right here. How does the perimeter, 0, 3, 6, 9, 12, how does that relate to the side lengths, which are here? 0, 1, 2, 3, 4. And of course, we can keep going. Well, hopefully you've tried to figure it out. But the way they relate is if I were to look at the side lengths as well as the perimeter is is 3 times the side length. Now, how do you know that's right, Mr. Oneal? Well, let's look at it. 3 times 0 is 0. 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. And then 4 times 3 is 12. So that's how I know, based also on the rule that they told us, the way the perimeter relates to the side lengths, what do they have in common? Is that the perimeter is 3 times the side lengths. Okay? All right, and we of course can keep going. If I said, well, if this was a 5 now, with that being said, right? If this was a 5, what then? Let me just write a 5. Hold on. Sorry. If this was 5, if that's the case, then the next one, the perimeter should then be 15. And if I were to graph that to see if that is true, we go from the origin, go over to 5 on the x-axis, and go up to possibly what 15 would be. And that would be right about there. And if I were to connect that now, I would actually be in line with my graph. So I know for a fact that that is 100% correct. All right, let's try another one. Hopefully it didn't seem too confusing, but let's try this one. A science class uses salt and water to make a salt water battery. The table shows the amount of salt needed for the amount of water used. So the amount of water in cups, if it's 0, the salt in teaspoons would be 0. If the water is 3 cups, the salt would be 4. If the water is 6 cups, the salt would be 8. If the water in cups is 9, then the salt in teaspoons would be 12. Okay, so here goes another question. How does the amount of salt, this is what they're asking about, how does the amount of salt needed relate to the amount of water used? What do you think? How does the amount of salt relate to the amount of water used? If you notice, if it's 0, 0, right, the amount of salt, hopefully, you can get this, but the amount of salt, if the water is 3 cups, the amount of salt is 4. If the water is 6 cups, the amount is 8 teaspoons of salt. So salt is increasing, right, by 4. Water is, of course, increasing by 3. All right. So how does the amount of salt needed relate to the amount of salt of water used? Basically, if we were to keep going, let's say this would be 12, right? Because that's increasing by 3. The bottom one we should be able to figure out, well, it's increasing by 4, so that's going to be 16. So how to write that in words? The way the amount, and it could be a variety of different answers, right? But we just want to see how could it relate to the amount of water used. The amount of salt, I'm just going to shorten it, relates to the amount of water. My board is messing up, so I'm just going to kind of shorten it of what I'm going to say, right? Is that if water, of course, is 3, we can say that the salt water is 4, right? It's almost like saying that from the water to the salt, it's increasing also by 1. So this is like, there's so many ways you could say this. This would be like a +1 between the two. This would be a +2. My board up. This would be a +3, right? In between those two, from 12 to 16, that's a +4, right? So we could say the salt is increasing by 1, like 1 more than the previous number. You could say that the water in cups is increasing by 3, whereas the amount of salt is increasing by 4. So there's a variety of different ways. So I'm just going to put dots here at the end. And again, if you don't understand what I'm saying, just rewind for what I said. If you're comparing and looking at water and salt from top number to bottom number, they're basically increasing by 1. So from 3 to 4 is by 1. From 6 to 8 is by 2. From 9 to 12 is 3. Therefore, the next pattern, 12 to 16, we can keep going by figuring out. We're just going to figure out the difference by increasing by 1. I know it might sound a little bit crazy, a little bit confusing, but just bear with me. B, so I put the dots so we can see that it increases based upon what I wrote there. Use the values in the table to write ordered pairs. So now let's take that and create ordered pairs. So we have 0, 0, right? We have 3, 4. We have 6, 8. We have 9, 12, right? Okay, so now let's use that. And let's go with it here. Hold on if my board works. Okay, cool. So I wrote it there. I have down what B is. Okay, 0, 0, 3, 4, 6, 8, 9, 12. Again, we could keep going. X is increasing by 3. Y is increasing by 4. That's a relation that they would have. That's kind of what Mr. Oneal was saying before. Okay. So let's say if we wanted to write that rule, if that was a question, X increasing, or I'll just put increases by 3, Y increases by 4. Okay, so that kind of would go back to the problem we had before that. Label the axes now. Graph the ordered pair on the coordinate grid. So now let's use those coordinates and go ahead and graph it now. So 0, 0, that's going to put us right there. Okay, 3, 4, again. Notice how the graph is. They're increasing by 4 there. So 0, 4, 8, 12, 16, 20. Same thing with the y-axis. So in between, we can figure that that's got to be possibly a 2. So 0, 2, this would be 2. This would be 6. This would be 10. Right? This would be 14. You see what I'm saying? All right. So the first one is 3, 4. So that means it's in between the 2 and the 4 right here. Okay? So I'm going to go to 3 and I'm going to go up to 4. That puts me right about there. If the board would work. All right, notice how it's kind of like in the middle. It's a weird spot for it, but it makes sense. Next would be 6, 8. So I'm going to go to the right on the x-axis to 6 and go up to 8. That puts me right there. Okay. Next, I have 9, 12. So that's in between 8 and 10 on the x-axis. And go to 12. So that's going to put me right about there. Okay. So I'm going to go ahead and connect those. I'm going to use different color here. I'm going to go ahead and connect those dots, right? Okay. It says D, if the class uses 15 cups of water, 15 cups, how much salt does the class need? So let's kind of go back to our chart. All right, cups of water. We figured out 12 cups. So let's say if it's increasing by 3, then that means this is going to be 15, right? And the question is asking, if the class uses 15 cups of water, how much salt? So let's use the rule. X increased by 3, Y then would increase by 4. So if that's 16, then that means this is 20. So how much salt does the class need? The answer is 20, I think it was teaspoons. $20 teaspoons of salt. Now again, Mr. Oneal, how is that true? Let's use the rule that we have here. X is increasing by 3, Y is increasing by 4. And I kind of kept going with that right here. This increased. 12 is 3 more than 9. 16 is 4 more than 12. So then if I keep following that same rule and keep going with the pattern, it's going to give me my answer right here. 15 cups of water, 20 teaspoons of salt. And I went ahead and answered the question. Okay? All right, ladies and gentlemen, so that basically is it. Hopefully you got it. Please, please, please go ahead and study for your test tomorrow that you will have. And again, strive for greatness.